Do you know how the solar system was formed? The answer to that question had a few theories for a long time. But due to the observations and studies of other galaxies, nebulae, asteroids, and other celestial bodies, one theory became to be the most accepted one. Hello my friends, welcome to the Horizon Seeker. Today we will use our special spacecraft to see the formation of the solar system. Stay with me until the end, because to see that, we will use our vortex to travel faster than the speed of light, and we will also go back in time. So let's use it to fast travel to outside of our galaxy. This is the Milky Way Galaxy, our galaxy, and this is where the solar system is, about 26,000 light-years from the center of it. Now let's go to about 6 billion years in the past to see what happened on the neighborhood of what now is the solar system. Before the solar system, next to where we live now, existed an ancient star that ran out of fuel and exploded into a supernova. According to NASA, since the Big Bang, that happened about 13.5 billion years ago, the stars live their lives, then run out of fuel and explode, sending their stellar dust to space, what we call a nebula. From these nebulae, other stars are formed and repeat the cycle. It is believed that our Sun is a third-generation star, formed from the remainings of the nebula of a previous star that exploded into a supernova, like this one. The supernova that formed our solar system was mainly made of nitrogen, oxygen, iron, silica, and all the other components that is needed to build the planets we have today on the solar system. Well, in some point of that nebula, at about 4.6 billion years ago, the cloud collapsed, possibly because the shockwave of a nearby exploding star caused it to compress. In the middle of that, the pressure was so great the hydrogen atoms began to fuse into helium, releasing huge amounts of energy, creating our proto-sun. The proto-sun was formed of more than 99% of the material of the disk. The remainder of the cloud formed a swirling disk called the solar nebula. Scientists believe that in the solar nebula, dust and ice particles clumped together because of gravity and formed larger bodies through a process called accretion. These larger bodies became planetesimals with the size of a few kilometers large. Close to the center, hotter part of the solar nebula, the planetesimals were composed mostly of silicates and metals. Close to the Sun, it was too hot to lightweight volatiles such as water and ammonia to condense, and they were pushed far off the center to a more cold area. In the outer, cooler portion of the nebula, they were mostly made of water ice. As the planetesimals got bigger due to accretion, they became protoplanets and then planets. Then, when the proto-sun received so much hydrogen from the nebula that fused into helium, nuclear fission began. The proto-sun ignited, becoming our Sun. The energy from the young Sun blew away the remaining gas and dust, leaving the solar system as we see it today. First, the ice and gas planets were formed at the edge of the solar system because these materials, ice and gas, couldn't stay close to Sun's heat. So Jupiter, Saturn, Uranus, Neptune, and maybe some other giant planets were formed that were thrown out of the solar system because of the giant's gravity. Then the terrestrial or rocky planets were formed closer to the Sun, like Mercury, Venus, Earth, Mars, and others like Theia that don't exist anymore. So my friends, this is how scientists support that our solar system was formed. If you enjoyed this trip and also want more, like the video, subscribe to the channel, and activate the bell, so YouTube will tell you when our next trip is ready to go. Thank you, and see you on our next journey.